Welcome to my Arduino Midi controller project. As you can see, based on an Arduino Mega. Nice graphics. This is a hobby of mine, so what this is a project for a DIY Midi controller. Foot switch controller, I should say. And there's three main components. The first is the physical housing, which I've already built. The electronic components that need to be mounted in and on this, and the programming. So this is my little project to show you how you can do it yourself and go through the second of those two steps, because I've already built the physical housing and there's no great science to that, although you have to be careful what you're doing. So the first thing I'll do is go through the dimensions of this thing and why it is the way it is. So what the constraints are, and go through it. So the first thing is the layout here has foot switches, or holes for the foot switches, mounted 7 centimeters apart. If you can see that okay. Let's see if the light is going to help us here. Where's this lighting angle? I never went to film school, in case you're wondering. There we go. You can sort of see where those holes are. They're 7 centimeters apart, both ways. And that seems to be what most manufacturers use, around about 7 centimeters apart, to give you enough room for your foot to operate them successfully. Each of these holes is for the switch. There will be single pole, single throw momentary switches, and the holes, smaller holes above them, are for indicating LEDs. There are a few other holes for mounting things. Also, this is the hole for the USB connector. This is a hole for a reset switch. There's a reason for that. And this is a cutout for an LCD display unit, a 16:2 LCD display unit. So that's all to do with where we're going, where the electrical components are going to be mounted on it. So your width and your depth are driven by the layout of 7 centimeters between each of these. And you can see how this one, there's a fair bit more of a gap there than there, because where the switch is to allow for the LED. And these are all, the midpoint of that hole for that switch is around 7 centimeters from the side of the unit. This is made out of plywood. It's about 7 or 8 mil plywood. That's strong enough for this. You don't have to make it out of metal or anything more robust, unless you're going to you're some kind of steroid taking hillbilly, like stomping on things. This is going to be strong enough. And also, there's not going to be any audio signals going through here, so electronic shielding is not an issue. So shielding's, you can put copper and all, copper foil and all that sort of stuff, but if you need shielding, you're better off just building it out of metal or aluminium or something like that. Okay, height, depth and width. Now the height is driven by the need to give some relief between the arrays of foot switch. It gives about 2 centimeters between. This one is about 2 centimeters higher than that one, and as is that one. So that's driven the profile of the side here. That's the first purpose. The second purpose is that it gives you room to mount components underneath. So this is 3 centimeters here, and this is 6.6 centimeters here. And if you work it out, and I'll just go to my graphics display. And if you're interested in geometry at all, see if I can get that in. Yes, 6.6 centimeters high. 3 centimeters high here. Translate, if you use Pythagoras' theory, of 203 here, 206 there. That's a 10-degree angle. and it's an 80-degree angle. So that's all based on the idea this is a right-angled triangle and you don't cut off at 3 centimetres. So they're roughly the dimensions. Give or take, I mean, I'm putting 6.6 millimetres. By the time you screw things together and sand them, it may not work out the way. So this is 34 wide. It is 202 deep. So 203 I said on my board, thereabouts. And if I turn it over and take this length here, it is about 206. Oh, I got that one right. Or close enough to it. Anyway, without being too exacting about it, they're roughly the dimensions. So you need this layout for the distance between the switches, provide enough relief to operate the switches, height between each one, and room to mount components. In particular, I'm using an Arduino mega board, so 7 centimeters is probably about the minimum to be able to fit an Arduino mega board between the switches, so that works out nicely. This is designed such that there is a cutout here for fitting a rear panel for inputs and outputs. You could mount them directly in the wood. I like having a separate panel to do that. The 4 holes in the corner are designed to screw into these sections here that are part of the construction. They're what each of the side members screws into those corners there, if you can see them there. Okay, and I've put a few sort of battens or whatever for mounting the top panel on. But one of the key things here is, you know, having done a few of these sort of projects, and for myself, is that you're always tinkering and playing with them. So having the panel mount this way onto these supports means that when I take the panel off, I can turn it over, mount it back in here, and work on it. So if this is designed to be mounted on a pedal board semi-permanently, it means that I can always, you know, conveniently get to all the components and fix it up and have it a steady mounting to be able to do modifications and maintenance, that sort of thing. And this cutout relief here is designed such that the panel, the connectors to the panel, will be in a single wire, or bunched together at least in some kind of loom, that mean that I can just slot through here, this hole here, like that. So when I turn it over, I've got some relief for the cable to go through. So I'll put a bit of foam there to keep the dust and whatever out. So that's the features of the physical housing. So that, you know, if you think it through, there's a few more things you can do other than just have a thing to put switches in. There's ways you can make it work better for you. That's what I'm doing. So you can do whatever you want. The way this will work, as I said, there'll be some brackets, 1, 2, 3 brackets. This will be a long one here, so that you can fix it on, screw it down onto a pedal board or however you want to do that, and that'll be the permanent fixture. I don't think there's anything else to talk about. This hole is for a 16x2 LCD display. I'll go through that when I start fixing the electrical components, but that's I made this bezel myself, so that just mounts on there like that, and that'll screw down. So the dimensions of this hole, you just work it out on what you need to do. So it's a bit like a cooking show. Here's one I prepared earlier. There's a bit of work in these things, but I'm not doing this to show you how to build a physical housing for the unit. But there's a few ideas in here that I've worked out through trial and error that you might find helpful. But I think that's it for this first step. The next step will be to look at all the electrical components and how they fit. Thanks, bye.